Okay, first of all, we'll just finish yesterday's notes. So make sure you're on day 7 and looking at number 5. Okay, right away we see that we can factor. Start with the easier one to factor, x minus 2, x minus 3. That usually gives us advice for what to do with our tougher factorization. And try our 2 and our 3, which gives us 4 and 3. So if I make those each negative, there we go. Now this is crucial. If you can reduce, you must reduce. If I were to graph it as is, I would have 2 vertical asymptotes. You know, I'd see something that has, 3 regions. It's either looking quadratic or cubic between. But as soon as I reduce this, I'm now left with y equals x minus 3 over 2x minus 3. So that's very different. Just thinking about that real fast, that's one vertical asymptote, very different than 2. You must reduce if possible. Okay, so vertical asymptotes from our new equation, very important. Vertical asymptote in this case is x equals 3 halves. And go to start to graph that. And then horizontal. I see that they, the numerator and the denominator have the same degree, therefore y equals 1/2. There is no oblique because there is horizontal. Zeros, remember we're using our new, our new polynomial function, or rational function. So here I'm going to let 0 equal x minus 3, and I'm going to end up with 3. My y-intercept will be 0 into our new rational function. We'll get negative 3 over negative 3, which reduces to 1. And in reality, that's what we need to graph. If you notice it, I have 1 point on either side of my vertical asymptote, so I'm not even going to test anything else. The only thing that I have left to do right now is to explain how to find a hole. You will only ever have a hole if you reduced your original rational function. And in this case I did. I took out the x minus 2. So what I do is I take what I took out, which was the x minus 2, and I set it equal to 0. And the whole of my problem is at an x of 2. Why we do this is if I were to put 2 back into my original, it would be undefined because I'd be saying it's okay to divide by 0. So in this case, I'm going to say 2, but now I have to plug this back into my new function. So plug into new function. Therefore, once again, I'm plugging in 2 into the x minus 3 over 2x minus 3, and I get 2 minus 3, or negative 1. And then I get 2 times 2 minus 3, or 1. So I end up with the ordered pair at 2, negative 1. And I actually put an open circle. It makes sense. Like I said, I didn't need to do any more points. I could have figured out how to graph this. Well, now we've got those 2 points. I'm going to connect them. But remember, I'm not actually going through that hole. That is the one value of x on there that does not work, in addition to my asymptote here at x equals 3 halves. And then I'm going to go through my other point. You're welcome to try 1 if you want, but I know it's bound by its asymptotes. Okay, sorry the graphs aren't so beautiful on this, but going through the whole again. You go to your original rational function, you look for what factor was reduced, and you set that equal to 0. So in this case, x minus 2 equals 0, so our x is 2. Then you must plug that 2 into your new function. If you plug it into the old, it would produce 0 in the denominator, which is why we have a whole. So I plugged 2 into my new, and I came up with -1. You just treat it like an open circle. It's a whole. And then we graph just like normal. Okay, so finish this up, and then go ahead and watch the day A notes that are really short. Have a good one.